And here we have a massive rational equation. So we want to solve for x, of course, and right away I'm going to do two things even before we get really started. The first thing will be to factor all denominators, just because then we see if we can cancel anything out, which will be great. And I will also look for restricted values for x. So I'll just copy things down for now. I have 5 over x times x minus 1 plus 1 over x minus 1. This is already factored and simplified, so I won't touch it. I'll leave it like that. Then I have 3 over x squared minus x. Now this I can factor, definitely. I can actually factor out an x. X squared divided by x is just x, and negative x divided by x is just negative 1. And over here, so I have 2x squared all over x cubed minus x squared. So now I can factor out an x squared, and x cubed divided by x squared is just x. Negative x squared divided by negative x squared divided by x squared is just negative 1. Okay, now let's look for restricted values. So over on the right here, we have x times x minus 1. We know that that cannot be equal to 0 in any way, shape, or form. So x cannot be equal to 0, because if it were 0, 0 times anything is 0, so that's a restricted value. And x minus 1 also cannot be equal to 0. So in this case, x cannot be equal to 1, because 1 minus 1 would give us 0. So far, x cannot be equal to 0 or 1. Over on this denominator, the restricted value would also be just 1, so we don't have to repeat it. Over here, we have the same thing as before, as over there, x times x minus 1, which would give us the same restricted values. And finally, over there, x squared times x minus 1. That's a restricted value of 0, again for x squared, and 1 for x minus 1. So we're done. These are the restricted values, and we can finally begin working on our equation. One thing that I can notice at this point is that we have an x squared here, an x squared there. Those can just cancel out. And now I will just multiply both sides of the equation by the least common denominator. That way I'll get rid of all denominators, and that's going to be a great thing in this case. So the least common denominator of x over x minus 1, and the same thing over here and over there will be just actually x times x minus 1. Since if I multiply both sides by that, all denominators will actually just disappear. Let's see how that's going to work. So I'll expand, or rather distribute, the x times x minus 1 over here. So I'll get 5. This x minus 1 is poorly drawn, but trust me, it's x minus 1. And we will multiply the 5. So we're going to get 5 times x minus 1 all over x times x minus 1 down at the bottom, right? Untouched. And why am I only multiplying the x times x minus 1 to the top, to the numerators? Because down at the bottom we have a hidden 1, right? And when we multiply fractions, we multiply top, top, bottom, bottom. So now I can distribute the x times x minus 1 over here as well. 1 times x minus 1 will be just x times x minus 1 all over x minus 1 equals. Now I can distribute that over here and over there. 3 times x minus 1, and we're gonna add, oh sorry, actually I forgot this denominator, so it's still here. X times x minus 1, and the final fraction that we're multiplying will be just 2 times x minus 1. This question's so long. And finally, x minus 1 times 1 is just x minus 1. Alright, now we can start canceling things out, which will be fantastic. The x's will cancel out, x minus 1s will cancel out, So here we're left with just 5. Over here, x minus 1 over x minus 1 cancel out. We're left with an x. Over on this side, x and x, they cancel out. X minus 1 over x minus 1 also cancel. So we're left with a 3. And finally, x minus 1 over x minus 1 is just 1. So we're left with a 2x. So over here, now we can solve for x. I will subtract 3 from both sides of the equation. Those cancel out. 5 minus 3 is 2. I can bring the x down. The 3's are gone. Bring the 2x down. And I will continue over on this side. So we have 2 plus x equals 2x. Now I can subtract x from both sides of the equation. They go away. So I get 2 equals 2x minus x, just x. And that is the final answer. And our restricted values were just 0 and 1, not 2. 2 is fully allowed. Therefore, that is our solution. X is equal to 2.